All right, looks like some people have filtered in. Let's get started. Hi, everyone. Thanks for joining me today for our session. I just want to jump right into it. For those of you that don't know, my name is Max, and for nearly 4 years, I've been a developer advocate here at Zoom. During that time, I've had a chance to work with our meeting SDKs, Zoom apps, and now our raw data streams. Today, I'd like to share how you can easily build something really cool with our ecosystem. Let's peek at our agenda. We'll start by learning about raw data and our sample apps. Then we'll tie it together with OpenCV. I'll play a brief demo to show it all in action before we wrap up and have some time for Q&A. To start, let's take a look at raw data. So what is raw data? Using our native meeting SDKs, you can create a bot that joins a meeting and streams audio and video data in real time. This opens up a whole new world of possibilities when it comes to integrating with a meeting and the users of our apps. We can then combine it with a Zoom app to engage with users and create new meeting experiences. Here we have the steps we need to take to get started with raw data. Frankly, the last two are optional. So in other words, we really work to make this as simple as possible to scaffold what would otherwise be an extremely complex architecture. Let's take a quick look at this journey. You can see it starts by creating an app in our Zoom marketplace. From there, you can download the SDK files that you need, and you can add that to a quick start along with your credentials. From there, we're ready to go. We can join a meeting, explore what's possible with this raw data that we have access to, and then extend it even further with a Zoom app, which is a web app running within the meeting. I'd like to take a quick moment to talk about our sample apps as well and why we make them. As you start your journey to accessing raw data and as a Zoom developer, you'll see that using these quick starts are instrumental to understanding best practices with our SDKs, and that's very much intentional. I have some general rules I like to follow. You can see here on the screen, and these are general rules for sample applications that we like to create. I won't bore you with the documentations, but I do want to set some expectations on what a sample app is and why we make them. For us, a sample app is for those that want to go from 0 to 60 as fast as possible. It should work as a quick start, as well as documentation on best practices and a jumping off point for those who want to go further. The sample app that we're going to be using today is the headless bot sample that I've created and modified for the demo. You can check this out on GitHub and specifically look at the Zoom Dev Summit branch for the code we're using today. Before we dive headfirst into our demo, I want to highlight just how easy it is to use OpenCV, which is the most widely used open source computer vision library. We're using it right within the Zoom raw data callback, and we have 3 steps here, which is really 2 steps. We're converting video from YUV to something we can work with, whether that's grayscale, BGR, or RGB. And then we're simply detecting objects. From there, now that we've detected objects or faces within a scene, we can innovate. We can add our special sauce and make a really cool app. Today, we're just going to be drawing bounding boxes, but once you have the ability to work with OpenCV, there's a lot you can do. All right, this is my favorite part, where we get to look at code. This is essentially the bare minimum we need to effectively detect faces on our raw video stream and then send the results to our Node.js server in real time. We'll show this code in action during our demo, but I want to point out how simple this is when it comes to image processing. First, we wrap everything in an asynchronous function so we don't impact performance. Then we're just converting our YUV image to grayscale, scaling it down, equalizing the histogram, and then detecting faces. We can then write over a Unix domain socket to let our Node.js server know that we found objects or that we didn't. All right, so I've been promising it. Let's get into the demo. But first, let's talk a little bit about our demo goals. This demo is really intended to show what's possible and inspire you to make something cool on our developer platform. Today, I'll use face detection because I think that's cool, but you probably have a better idea, and I encourage you to go out there and make it. Looking at the architecture for our demo, We have a Docker container on the left-hand side with our backend code and a Zoom meeting that's running in an in-meeting web application. Sorry, a Zoom meeting that is running an in-meeting web application called a Zoom app. Our C++ application receives those frames of raw video and processes them with OpenCV in real time before communicating to our Node.js server. From there, Node.js serves a web app that runs directly within the Zoom meeting. And now let's play a short video and take a look at our demo. Hello, thanks for joining me for a quick demo on using our headless Linux sample along with OpenCV. As you can see here, I've already got our GitHub page open for the sample app, and I'm on the Zoom Dev Summit branch, which has been modified to work with OpenCV for this demo today. So I've cloned this app to my local system, and I've gone to the Zoom app marketplace, and I've created an app there. Now that I have my credentials, I've moved these over into the configuration file for our sample app, and it's ready to go. If you're looking to set this up yourself, we have some videos and blogs going into more detail on exactly how you can set this up. But for today, I really just want to showcase the modifications we've made for the demo today. So I'm going to breeze past that stuff, but please do look at our documentation and our YouTube channel for more details on getting started. So since I've configured everything in our app, let's move over and take a look at that. As we can see here, it's a C++ project, but I also have a client folder with a Node.js application. And that Node.js application is going to consume data from this meeting and interact with the Zoom client. If we look at the window with our code here, this is code that I've shown you previously, and this is really all it takes to use that raw data callback to process the YUV frames, detect faces, and do so much more. So I'll go over this really quickly because I know this is something we've covered in a previous slide. But just looking at this right here, we're taking our raw data and putting it into an OpenCV matrix. Then we're converting the color to grayscale, and we're resizing that image so that it's smaller and easier to work with. On that smaller image, we're going to equalize the histogram, and then finally, we can efficiently detect faces on this image. From there, all I'm doing is sending the amount of faces that we found over a Unix domain socket. You could really be doing anything here, but this is just a simple example of what's possible. And then every other frame, I'm going to draw a rectangle around the faces that we've detected, and I'm going to show that in our preview. And the reason I do this is just so that I get a live preview, but it's not necessarily running every single frame. I could even slow this down quite a bit more if I wanted to. Great, so let's spin up this Docker container and see how this works. This project uses Docker Compose. So I'll type Docker Compose up, and it will build a C++ application and start our Node.js server. Here you can see it's joined the meeting to record. Perfect. So now we have a preview window here with a rectangle around my face. But what I think is a lot more interesting is seeing this from the perspective of a meeting user, right? So right now we have this bot that's running, and in the background it is running facial detection, but I haven't really gotten a benefit as a user of this meeting just yet. So let's open up our Zoom app and take a look at what that offers us. So here we have a beautiful and striking UI. Basically just some text to tell if there's someone on camera or not. You can see that it responds very quickly. You could probably put a threshold on this or something so that it wasn't reacting immediately and was really only responding every few frames. But in an interest of just showing how quickly this can operate, I just wanted it to update as quickly as possible. So you can see that if I cover the camera, that there are no people on camera. And if it's just me, there's one person on camera. And if I even take this creepy vase that I have, it'll say that there are two people on camera. So this is just a really basic example of what you can do. Hopefully this inspires you to kind of get into the world of real-time image processing when it comes to Zoom meetings. And I hope this was helpful. Thank you. Great. So with that demo, I hope that has inspired you to go out there and make something awesome with the Zoom developer platform. Really, all I want to cover is what's next for you as a Zoom developer. And whether you're a new Zoom developer or an experienced one, these next three items are going to be crucial for you. So we started with our sample apps today. Make sure you check out our other sample apps on our Zoom GitHub page. We have our award-winning documentation, as my colleague O just likes to call it. So make sure to check that out to stay up to date with how to use everything. And then finally, please do engage with the community through our developer forum and let us know if you run into any snags using these sample apps or getting started with raw data. Next slide, please. Let's just open it up for Q&A now. So if there are any questions about how you can build the app of your dreams, or maybe how I built this app, or any challenges that I faced while building it, please let me know. I think something of note with this architecture is that I had the OpenCV processing done on the C++ side. In other implementations of this, sometimes I'll move processing over to the Node.js side. If the SDK is easier to work with and I'm willing to take that performance hit, then we can kind of mix up the architecture diagram a little bit. Leave it open a couple more minutes for questions. I'm trying to think if there's anything else I can talk about. So I have a question. It says, before you got into OpenCV, did you look into alternatives? Yeah, so I think my initial thought was to go with OpenCV because that's what I have experience with. I've tried using dlib with this project as well. I didn't think that dlib worked as intuitively for me, and that especially came down to a lot of the color conversion. OpenCV just makes it really simple to take my YUV I420 image and turn it into grayscale. And it does that really efficiently. dlib wanted me to compile it with special options, and it really wanted me to go through a large process to integrate an FFmpeg demuxer into it. And so while OpenCV was a little bit harder, a little bit trickier to compile, I think in the end it was worth it over dlib. But you can really use any computer vision library you want to here, whatever you have experience with. Thank you for that question. Excellent. Well, if that's everything, I'll wrap up this session, but feel free to catch me on the developer forums or on GitHub working on the sample apps. Thank you.